We all think of AI as this lightning-fast, futuristic thing, right? But what if I told you one of its biggest problems right now is that it's actually kind of slow? Today, we're going to dive into a really clever solution called speculative actions that promises to fix that, making our AI agents think and act a whole lot faster.
So, let me start with a question that might surprise you. If AI is so powerful, why can a chess match between two world-class AIs take over an hour to finish? Turns out a huge chunk of that time isn't the AI doing some deep strategic thinking. Nope, it's just waiting. And this waiting game, it's not just happening on the chessboard.
And I mean, it's everywhere. Look at these numbers. From managing your computer's operating system to doing deep research, we're seeing AI tasks take anywhere from 10 minutes to over an hour for just a single run. Now, this isn't just an inconvenience. It is a massive bottleneck that's holding back the real potential of AI.
This brings us right to the heart of the problem, what the researchers call AI's waiting game. So what's the deal? Why is this happening? Well, the answer is surprisingly simple, but its effect on performance is huge. Here it is. The big problem is that AI agents think in a straight line. They take a step, like making a call to a tool or another AI model, and then they have to just sit there and wait for the result to come back before they can even begin to think about the next step. It's a one-at-a-time process, and all of that waiting really adds up.
So this whole situation led the researchers to ask a really crucial question. Do we have to be stuck in this slow, sequential loop? Is there a better way? Could we break out and actually use all that idle time for something productive?
And that question, well, that's where the solution starts to take shape. And what's so cool about it is that it's not some brand new, out-of-the-blue discovery. It's an idea inspired by a trick that's been making our computers faster for decades. The answer is a big, resounding no. We do not have to wait. The solution is to have the AI agent guess what's going to happen next and just get a head start. This is called speculation. And believe it or not, the processor inside your computer has been using this exact trick since the 1960s to speed things up.
You can actually see how this idea has evolved over time. It started way back in 1967 with microprocessors guessing which instructions to run next. More recently, in 2023, it was adapted to help large language models spit out text faster. And now this research is applying that same core idea to the entire world of AI agents.
So how do they pull this off? Well, the researchers created a framework with two key roles. You can think of them as two different personalities working together as a team, the actor and the speculator.
Look at the difference here. The old way on the left is just painful. Step, wait, step, wait. But check out the new speculative way. While the official step 1 is still running, the system is already predicting what step 2 is going to be and starting it in parallel. It brilliantly turns all that dead waiting time into productive work. Okay, so first up, you've got the actor. This is your main AI model, the big, powerful, authoritative one. It does the heavy lifting, the deep thinking, and its decision is always the final, correct one. It's like the wise master who takes their time to get things perfect. And working right alongside the actor is the speculator. This is a smaller, way faster, and much cheaper model. Its only job is to make a quick guess about what the slow, wise actor is going to do. It's like the quick apprentice, trying to anticipate the master's next move to have all the tools ready to go. So here's how it all comes together. The slow actor starts its task. At the exact same time, in parallel, the fast speculator makes a guess about the outcome. And, this is the key, it pre-launches the next step based on that guess. Then, when the actor's official result finally comes in, the system just validates the guess. If the speculator was right, fantastic, we've saved a ton of time. If it was wrong, no problem at all. The speculative work just gets tossed out. It's a lossless speedup, giving you all of the benefit with none of the risk. Now, this all sounds great in theory, but does it actually work? Well, the researchers put this framework to the test across a whole range of different environments, from that slow chess game we started with all the way to tuning a computer's operating system in real time.
Let's go back to our chess example. While the main AI, the actor, was deep in thought calculating its best move, the speculator wasn't just sitting idle. It was busy predicting the opponent's most likely responses to get a head start on the next turn.
And the results were seriously impressive. Just by predicting the top 3 most likely moves, the speculator was correct over half the time, 54.7% to be exact.
That accuracy translated directly into a massive 19.5% reduction in the total game time.
I mean, just think about that. Your AI is now nearly 1/5 faster simply by using its waiting time more intelligently.
And this isn't just for games. In an e-commerce chatbot, it predicted the right next step 38% of the time, letting the agent respond faster than a human can even type. During a web search, it guessed the correct follow-up query 46% of the time, while the first one was still loading. This approach is incredibly versatile.
Okay, so far we've been talking about a lossless system, where we always wait for the actor to confirm everything. But what about those high-stakes, time-sensitive situations, like managing a live computer system, where waiting 15 seconds for the wise master could be a total disaster?
Well, that calls for a more aggressive strategy, lossy speculation. The idea here is simple. The fast speculator's action is applied immediately, without waiting for any confirmation. Then, when the slow actor's wiser decision eventually arrives, it just overwrites that initial action. It's a philosophy of act now, get corrected later.
And the payoff is huge. The researchers used this to tune an operating system in real time. The untuned system had a pretty high latency. The slow actor alone managed to cut that almost in half. But the combined speculator and actor system, it dropped the latency by nearly 2/3. By reacting instantly, the speculator keeps the system responsive, while the actor does its deep thinking in the background.
So, what does all of this mean for the future of AI? Well, it really points toward a fundamental shift in how we design and build these intelligent agents.
So what are the big takeaways here? First, this technique absolutely breaks that sequential bottleneck that's been holding AI back. Second, it provides a lossless speedup by turning idle time into productive work. Third, it's a general solution that works across all kinds of different AI tasks. And most importantly, it unlocks a path to AI systems that can finally operate in real time. And that leaves us with a final, really exciting question. We've all gotten used to that slight pause, that thinking time when we use AI. But what could we build if that delay just vanished? What becomes possible when our AI can finally keep up with the speed of our own thoughts?